Today we are going to work on solving quadratics by factoring. Everything from our last unit comes back. Everything. So here is our situation. You're finishing a stained glass hanging that your friend has started. You have enough supplies to add 6 feet squared. You're going to add 6 feet to the total area. You are going to add the same amount. You don't know what it's going to be, but you're going to add the same amount to both sides. We are going to figure out the dimensions of the new stained glass hanging. If you're going to add 6 feet of area, what's the new area for your new stained glass? Why 12?
Because you're adding 6 feet squared plus 6.
And where are you getting the other 6 feet squared? Yeah, the area of the current stained glass is 3 times 2, which is 6. If I'm going to add 6 more, then I would end up having 12 total. You had it. Don't let go of your thoughts. You were right. We already found the original area. How can I represent the length and the width of the new figure? What would the width be? 3 plus x, or x plus 3. Order doesn't matter. And then how about the length? 2 plus x. And how would we find the area if we knew that our length was 3 plus x and our width was 2 plus x? Yeah, we can distribute, because to find the area of a rectangle, what do? Yeah, we multiply our length times our width. And what do we know the total is going to be here? It's going to be 12. Could you think of a value that would work? What could x be? What am I going to add to each side?
1.
Yeah, we can add 1. Skipping ahead. Okay, so the value of 1 here would be the solution to this quadratic. We did not factor it. This is just a glimpse into how we can use a quadratic to actually solve. We can factor to solve a quadratic, and that's what we're going to work on today. You've already done a lot of work with factoring. Don't be surprised or discouraged if the factoring is still the most challenging part. And even though we're learning how to solve a quadratic using this process, the factoring is still what gets people a little hung up. Don't be frustrated knowing that we did it last unit. If you don't factor all the time, it's something you could struggle with. So we can solve quadratic equations, including equations where that b value isn't 0, by using the zero product property. What we're talking about today are quadratics of this format, where we have an a value, we have a b value, and we have a c value. We're going to use something called the zero product property. So what the zero product property means, you already have worked with this before. For any real numbers, a and b, if you multiply a times b, and you know that your total is 0, so a times b equals 0, then either a has to equal 0 or b has to equal 0. The example would be there. If x plus 3 times x plus 2 equaled 0, then either x plus 3 equals 0 or x plus 2 would have to equal 0. And you've said that before, because I'll always say, what's anything times 0? And you know it's 0. Right? That's not necessarily new. We're just adding a term to that understanding, to that concept. And the idea of these two terms being equal to 0 comes into play here, because when we write our quadratic equations in standard form, the standard form of a quadratic, we write it in the format ax squared plus bx plus c equals 0. example. If I know that this term times this term equals 0, that means one or both of them has to be 0. So I can actually create equations. X plus 3 equals 0, x plus 2 equals 0. Could I solve those? How would I solve that for x? X equals -3. How about here? So you just found values of x that would make y 0. What did you just find? The solution to quadratic. And we're using the zero product property to do that. So let's look at this example. If I already had this factored out and I had two terms, 4t plus 1 is one binomial, and t minus 2 is another binomial. How would I find the solutions? I can set each term equal to 0. Again, the idea is if I know that those two numbers times each other equals 0, one or both of them has to be the value of 0. So I can set both equal to 0 and solve. How would I get t by itself here? Subtract 1 for both sides. And then what?
Divide by 4.
And then divide both sides by 4. So t equals -1/4. How about this one?
Plus 2.
Add 2 to both sides. So t equals 2. So by finding those solutions, what did you just find? What does it look like on the graph? Where would you find those two solutions on the graph? What about it? Yeah, it's going to be where our parabola crosses the x-axis, where x is 2. And I know we're saying x even though the variable there is t. But if we're looking at that x-axis where x is 2 and where x is -1/4, so our parabola will look something like that. So without focusing on factoring, we're just going to work for just a few moments on using the zero product property. Okay, so for this first term, if I know that x plus 1 times x minus 5 equals 0, then that means either x plus 1 equals 0 or x minus 5 equals 0. If this is the case, then what is x here? -1. And how about here? X equals +5. I want you to take 4 minutes and try the other 3. Using the zero product property, find the value for each variable. Find x, find y, find n. Don't write it. That is your answer. Anyone want to do this one up on the chalkboard? 2x plus 3 times x minus 4. 2x plus 3 times x minus 4. Go ahead. How about 2y plus 1 times y plus 14? And 7n minus 2 times 5n minus 4. as your classmates are finishing putting those up on the chalkboard, think about why we are able to set both terms equal to 0. If both of those terms, each of those parentheses, is multiplying by the other, and I know that the total is 0, using the 0 property, one or both of them would have to be 0. Alright, so let's take a look at the first one here. Kate set up both binomials to equal 0. So we have 2x plus 3 equals 0, and the other binomial is x minus 4 equals 0. Once you get to this level, you're solving a 1 or 2 step equation. There's only variables on one side. That brings you back to like a early 7th grade equation solving standard. We will talk in just a moment about factoring prior to this. But once you get here, you're isolating your variable to get it by itself. Subtracting 3 from both sides gives us 2x equals negative 3. Divide both sides by 2. X equals negative 3 halves. And the other equation is actually just one step, adding 4 to both sides. X is 4. Ibrahima did the same thing here. 2y plus 1 equals 0. So getting y by itself, subtract the 1, and then divide by 2. You have y equals negative 1 half. Y plus 14 equals 0. Subtracting 14 from both sides, y is negative 14. And then Zara did our last one here. 7n minus 2 equals 0. Adding 2 to both sides, 7n equals 2. Divide by 7 to get n alone, n equals 2 sevenths. 5n minus 4 equals 0, adding 4, and then dividing by 5, n would be 4 fifths. You most likely wouldn't have to plot those points. Having the solutions is enough. You'll see that as we get deeper and deeper into solving, your answers are going to be a little different. Last week when we were graphing, we were dealing with answers of like 1 and negative 1, because on the graph, the key was to see where the lines crossed. Here we're actually going to start seeing some values that are a little bit different. So we can use the zero product property to solve quadratics of this format if the quadratic can be factored. So now we're going to take a look at a trinomial that is in its original standard form, and we're going to solve. So if we have the quadratic x squared plus 8x plus 15, how am I going to factor that? Who remembers how to factor that?
15
Okay, we can multiply 15 times 1. Now what?
and then find the factors of it that add up to the middle term.
Factors of 15, good, that add up to 8. Okay, 3 and 5, and then what can we do with those?
And then substitute it.
Yeah. Okay, so you have a couple of options. If you're going to use the process for factoring, when we have a coefficient, a value, you could. Okay, in this situation, when we first learned how to factor, we had a coefficient of 1. We had, dare I say the word shortcut, but we had a quick way that we could factor a trinomial like this. Because once we found those factors of 15 and 8, what could we do with them? Did I need to break it out into a 4-term polynomial at this layer, like with a coefficient of 1? If I FOILed out 2 binomials, what's the only thing I could have multiplied by to get x squared? What are our factors of 15 that add up to 8? 5.
5 and 3.
If you have a coefficient of 1 with that x squared, you could factor it faster. Now, what Ibrahima was walking us through was if we had a coefficient greater than 1. So if we had this quadratic, we can multiply 15 and 1. We could break it out. And then we can find the greatest common factor of each. Greatest factor of each. And I'd still be left with x plus 3 and x plus 5. As we talked about in our last unit, this process works for any quadratic if you have a coefficient of 1 or greater. This process, this little shortcut, would be if your coefficient was just a 1. So at this point, I have factored. And now my equation is this. So after factoring, I can use the zero product property. If I know that x plus 3 times x plus 5 equals 0, that means that either one or both of those binomials has to equal 0. So I can actually set them equal to 0. X plus 3 would equal 0. X plus 5 would equal 0. What would x be in both of these situations? X would be negative 3. And x would be so we have our solutions. We factored, we used the zero product property, and we found that x is negative 3 and x is negative 5. What will I see if I look at a graph and I have this quadratic on there? I know where the two solutions are. Okay. How do the solutions relate to the axis of symmetry? How would I find the axis of symmetry for that line? Remember how we find the axis of symmetry. Check your notes. Look back to what you wrote down. You worked with it for like a day and a half. You don't necessarily have to have it memorized yet. Say again. Negative b over 2a. What would that be for this equation? Negative 8 over 2, which is what? So our axis of symmetry is where x is negative 4, and our solutions are where x is negative 3 and negative 5. How are they related? They are all negatives. What do you notice about the solutions, though, in comparison to the axis of symmetry? Hmm? How in between?
Negative 4 and the other two are negative 3 and negative 5, so it's like
So both solutions are what compared to the axis of symmetry? They're both 1 unit away. They're the same distance away. Does that make sense when we think about what the axis of symmetry represents for our parabola? What is the axis of symmetry supposed to do for our graph? I see you doing it with your hands. What is that? What's the word we can use for that? What does symmetry mean? Yeah, it's the same on both sides. So if that is symmetrical, then a point that's 1 unit to the left of my axis of symmetry, I'd have the same I'd have the same coordinate 1 unit to the right. So if you find the solutions of a quadratic first, you could, depending on where they are, quickly find where the axis of symmetry would be depending on the values, because it's going to be right in between them, right in the middle. Okay. So let's try this one. You don't have to necessarily do this on your, I always write communicator, but In years past, I've had students who don't like to do it on something that erases. They'd rather have an example in their notebook. If you'd rather write it on something that can erase, that's fine. If you'd rather have an example in your notebook from start to finish, then keep it in your notebook. Sometimes with this material, it gets a little bit easier the more you see it from beginning to end. So here is our quadratic. We have m squared minus 5m minus 14 equals 0. How will we solve that quadratic, finding the points of intersection from start to finish? Do it in your notebook. Yeah, you're just going to do it. Okay, how am I going to factor this trinomial? What am I looking for when I factor this? I'm just factoring. What do I look for to factor a trinomial? How am I going to factor it? Do I want to multiply by m?
Oh, no, 1.
Okay. So 4 factors of negative 14. That adds up to negative 5. Whatever. Okay, so if I have here a negative 7 and a positive 2, my first term is an m. I don't have a coefficient, so even though that's your process, we don't have to go through all of that right now. If you do, though, that's fine, right? If that's your way, your way is to multiply the a times the c and then break it out into a 4-term polynomial, do that. I'm not always going to do that strategy when we have a coefficient of 1, just so you're still used to seeing both methods. Once I'm at this level, what am I going to do to solve? Yeah, I'm going to set both terms equal to 0 using our zero product property. And what are our solutions? Yep, I'll add 7 to both sides, so m equals 7. And then I'll take 2 away from both sides, so m is negative 2. And you're done. Try one more. One more. Not that one. Actually, maybe we'll do 2 more. There's one underneath. problem are we facing right now? Okay, so if there's no coefficient in there, what is that number? A 1. Okay. So that's our problem. Be careful with your terminology. There's the solution. But what's the problem with this quadratic? Where are you getting stuck? Yeah, finding factors of -50 that do what? That add up to, are there factors of -50 that add up to 1? No. Is that possible? Can a quadratic not be factorable? It can. There's a chance that quadratics won't be factorable. Now, you're going to learn next week. No, you're not. You're going to learn after spring break that if you go through this process, and I encourage you, try to factor first, because that will be the one that is the most familiar, especially because we spent an entire unit just factoring. If you get to a point where you cannot factor, there are other options for you to go to finish the quadratic, mainly the quadratic formula or a process called completing the square, one of which we're going to learn next week. Quadratic formula you're going to do after the break. But as you're going through the process of solving a quadratic, there are many different ways. I don't want you to think that everything is factorable. Up until this point, every quadratic you've tried to factor has factored. Our entire last unit, you didn't really have any that didn't factor. But that is a possibility. So don't rack your brain like, oh my gosh, I can't find these numbers. There really might not be numbers that factor. You'll have other options to go to continue to solve. Let's try one real one. This one really will factor. Sorry. I hope. Now, I intentionally put one here with a coefficient before the x squared, just so you have to recall how to factor a quadratic with a coefficient greater than 1.
You said we're learning something new.
Factor. Start with that. Factor the trinomial.
Isn't this that thing that I wanted to learn last time?
Yeah. Factor the trinomial will get you all caught up.
And that means no more grafting after we solve them?
For the most part.
Which one are we factoring? All of them?
The bottom one we did this afternoon. If you're hitting a roadblock with factoring, go back through your notes. You have everything detailed through from our last unit on how to factor if you have a coefficient of 1 or greater than 1. We're solving quadratics by factoring. Anyone want to walk us through how to factor this? I'm not coming to you because I already know this is your go-to method.
No, I'm not.
Oh, you have a question?
No, not the longer. I was gonna do that. I was gonna
That's the longer method. I don't know what someone else. So the other examples, when we had a coefficient of 1, we were doing this method for those. The other one you walked us through. The first one.
Yeah, that was for the first one.
I'm gonna skip you because I already know you know this way. Who wants to help me out? Except for Avery. Dun, dun, dun. All right. Where do I begin if I'm factoring a trinomial that has a coefficient greater than 1?
Multiply the A value with the C value.
And what are those two values here?
2 and A.
Yeah, I'm
And
gonna
2 and
multiply the 2 and the 18 to get what?
36.
36. Somebody else, what am I doing now? Aurelia. Yeah, I'm going to find factors of 36 that equal negative 15. So factors of positive 36, that's a positive. It's still supposed to be a positive. That equal negative 15. Who could tell me? Somebody else. What are the factors, David?
Negative 12 and negative 3.
Negative 12 and negative 3. Negative 12 times negative 3 is positive 36. Negative 12 plus negative 3 is negative 15. Somebody else, what do I do with those?
You make a 4-term.
Patrick, say it.
Make a 4-term.
I'm going to rewrite this trinomial as a 4-term polynomial. 2a squared is the same. I'm just breaking out that negative 15 to negative 12 and negative 3. Does the order matter there, or could I put the negative 3 first? Doesn't matter. Good. Somebody else, what do I do now? Laura.
Now you have to find the greatest common factor between
All
all of the values.
of them?
No.
Well, between the first two and
Yeah, I'm going to find the greatest common factor from the first two terms and the greatest common factor of the last two. Basically, I'm reverse foiling. I multiplied something here, which gave me this. And then I multiplied the second term by the same parentheses to get these two terms. What's the greatest common factor of the first two terms? 2a. What's left?
A minus 6.
A minus 6. If this parentheses is a minus 6, the other parentheses is
A minus 6.
a minus 6. What factored out of negative 3a plus 18?
3.
A negative 3. So, I'm not done yet. What are the two binomials that factor out?
2A minus 3
2a minus 3.
and A minus 6.
Now what? So then I'm going to write, say it a little bit louder. 2a minus 3 equals 0. And what else? Who can remind us, why am I setting both of the binomials equal to 0? Look at your notes. Be detailed. You have classmates who are in here for this part.
Yeah.
No pressure. Why am I doing this? Why am I able to do this?
Would it be because both of them together have to be 0, so then apart they have to be 0? Because nothing plus nothing could be 0.
Well, we're not adding now.
Well, either way, I'm close. I'm around.
You're around there. You're almost there.
Someone tell me.
What's it called? Say it louder. Somebody did. What do we call it? The zero product property, right? Which is something you've learned before. Means that if I am multiplying two numbers and they equal 0, that means one or both of the numbers has to what? Equal 0, right? Anything times 0 is 0. So if I already know my answer is 0, one or both of these has to be 0, which is why I can set both equations equal to 0 and solve. How do I solve for a in this left equation?
Plus 3.
Add 3. 2a equals 3. What's a? Divide by 2. A is 3 halves. How about this one?
Plus 6.
What did we just find? The solution to the quadratic. This quadratic will cross the x-axis at 3/2 and at 6. I don't know if
And then we could graph that.
At this point, you probably wouldn't be expected to graph that.